and good morning. Today I'm actually going live to do some support with some of our students. I was on this morning and thinking about how I could actually help and support different types of families who are all home right now working with their kids. And even though there's virtual learning in classrooms, I know tons of families are worried, how can I continue to help my kid? My kid's still struggling with work. And so I decided, I want to help and support. So I went on a few chat rooms and just asked the question, who needs help? What's going on in math? And I got a few responses already, and some people who had already asked me questions and wanted to know, can you please go live? Can my kid really need some support? And so what I did was I just took some of the topics that came up already in DMs and messages from friends sending me pictures, and I'm just going to go through some of those topics. And if you have more topics, you can gladly just DM them to me. You can send them to me live, and I will be sure to answer. And I'm also going to go live again at 3 and at 6. I did try to post this on a few of the chat rooms where I saw some questions come up, and I'm going to just post there as well so they know they can actually watch the video if you need some help. So I'm just going to type that out to some of the kids, some people in the group, so they know as well. If they would like, they can meet me there, especially since they were the ones who had that question. So let me just put that up there to them. Follow me on my Facebook wall. And catch me live now. So just sending that out. Okay, so it looks like I already got a message just saying hello, hi. Hi, Jose. Okay, so we're going to start with the first one that came up, which was from a little girl in Connecticut, and it had to do with partial quotient division. And for most of us, we know to use the regular traditional long division, which just looks like this. And a little girl had this problem, and she was using something called partial quotient. When we're doing traditional division, a lot of times we have to remember all these steps. Like, we're supposed to divide first. We're supposed to look at a number at a time, figure out how many times does 7 divide by 4, put that number up here, multiply, subtract it, bring it down, all these different steps. Subtract, bring it down. And a lot of kids have a hard time remembering these steps. When I taught 4th and 5th grade, so many kids struggled with just remembering steps. They were so complicated, and so much of the math is hidden because we don't necessarily see what's happening in this type of problem. There's so much math hidden, so we don't see that there's dividing here, that they're multiplying this times this to get this number, that they're then subtracting this and bringing down this, and then dividing again. Where do these numbers come from? So to start off with the idea, what a lot of schools start off with conceptually is something called partial quotient, and that is kind of like evenly sharing. So imagine when you go to Party City and you got that big bag of candy, like 500 pieces of candy, and you have to make all the little baggies of candy, and you want everybody to have the equal amount. So we think of it as almost an equal share. And in the beginning, you have no idea what everyone's going to get, so you kind of just grab and give everyone the same amount. That's kind of the same idea with partial quotient. So I'm going to do the same problem, 71 divided by 4. And what we're going to do is we're going to think, what if I can't do the division? How many sets of 4 do I continue to take out? And the trick for this is, for kids, use really friendly numbers. And for kids, those are numbers that they can easily multiply, like 5s and 10s, those numbers that they know in their head that they don't have to think through. And you're going to try, I'm going to do a little representation. Try and think that you have 4 groups, and how many are you going to give each group? So you're going to start off with 71. And some kids go, all right, what if I gave everybody 10? Okay, so first you gave everybody 10. So 10 groups of 4 is 40. So that was the first thing you did. You gave everyone just 10. Okay. Then you think, all right, if I gave everybody 10, I have 31 left, right? Then I tried to give another easy number, and for kids, this can be friendly. What if I gave everybody 2 more? So I've taken out 2, 4, 6, 8. So I took out 8 more. Okay, so I took out 8 more, and that's okay. I still have 23 left. Oh, 23, that's very close to 20. And I know that 4 times 5 makes 20. So I'm going to give everybody 5 more. 5, 10, 15, 20. So I'm going to take 20 away, and now I have 3 left. Now I don't have enough to share because I have 3 pieces of candy, and I can give these 3 one, but I don't have one for this one. At this age, a kid isn't thinking about breaking into smaller pieces. They're not ready to look at division. If they're doing partial quotient, they're probably just using a whole remainder at this time. All right, so how much candy did each kid get? Every kid got 10 pieces, then 2 pieces, and 5 pieces. So everybody got 17 pieces when we add it together. So I know that I can give out 17 pieces and still have 3 left. And this is kind of how partial quotient works. It's just kids deciding what kinds of numbers they want to use, and then they're just, imagine you're taking it out of the back and you're just taking it from the group over here. So that's kind of how it works. I can actually use different numbers. There's no set way, and that's what's really nice about this, that kids can subtract in different ways. So let's say, for example, a kid starting over, and we're going to get the same exact answer. Let's say a kid starts over, and their method, they start and they want to give everybody 5 pieces first because they really like the number 5. It's so funny. 5 times 4 is 20, and they have 51 left. And they're going to do it again. They want to give everyone 5 again because it's so easy. I like subtracting 20s. I have 31. I'm going to take out another 20. So you're going to give everybody 5 again. And now they have 11 left. I don't have enough to give out another 20, but I can give everybody, let's imagine the kid decides I'm going to give everybody 1 piece. They still have 7 pieces, so I can give everybody another 1 piece. And now I don't have enough, so I'm done. I give everybody their pieces. And I can still add it up together, and everyone got the same. Remember, these are equal groups. And I have 5, 10, 15, 16, 17. See, it still works. Everybody still gets 17 pieces, and you still have 3 left over. So this is a really great method if you're just starting with the idea, the concept of division, where you want kids to understand that everyone is getting the same. It's an equal share, but they don't necessarily have to know their math facts to do this type of division. Okay, so let's look at some of the other ones. Hopefully that makes some sense over there, and we're going to look at base 10. And this problem came from a mom this morning. I don't know her. I think her name is June, and she shared this problem with me that her kid was having. And her kid was doing place value and had a really interesting question. Let me find it on my phone. So they were trying to understand what happens when you move a decimal over to the left and to the right. So for example, her kid's homework kind of looked like this at first. And they were trying to show the example of like what's happening each time. And you can see each time I have a 0 added, 0 added, 0 added. So I know my number is getting bigger. The other thing I want to point out is that this decimal, we're going to make it visual. We're going to pop it for a minute because that's going to be real important for us in terms of place value. And her homework question was asking, or trying to get them to see that if I'm going from, let's say, 5 to 500, how is my number changing? It's growing, definitely, but we're going to use this idea of base 10, our base 10 system. So for example, from 5 to 50, it is now 10 times bigger. From 50 to 500, it's 10 times bigger. But from 5 to 500, it's now 10 times 10, 100 times bigger. Okay? So it's this idea that numbers are getting bigger. And I was looking at the girls' worksheet, and I thought, how can this be any easier? So I got it. What if we go to numbers in this way? Here's a 5, here's my decimal. If I want numbers to get bigger, where should my decimal move? I'm going to move to the right. So when my decimals move this way, it gets bigger. Every single time I move it one place, it gets 10 times bigger. So 50, if I move it 2 times, it's moved 100 times 100. If I move it another time, it's moved 10, 100, 1,000, okay? If my decimal moves this way, it's getting smaller. It's getting 1/10 the size. So it's almost like dividing by 10, but in the girls' homework, it said you're multiplying by 1/10. Same thing. So if I multiply 5 times 1/10, I'm getting 5/10 or 0.5. So same thing. Or if I'm moving it again, one more spot, so I have to put that in there. Now I've gone from 1/10 to 100th. Okay? So just this idea. So if I'm moving to the left, then it's going to get smaller. That's kind of what's happening. So the girls' homework was really interesting because it gave them a number sentence. And we're going to use this rule to figure out what's happening. And it said the 4 in 153,438. So this 4 has the value of the 4 in 192,946. So I'm comparing this to this. Okay? So I have 400 is equal to 40 times some number. So you're going to think about this 40 over here. Here's my decimal. What way do I have to move that decimal to get to 400? It's going to get bigger, so I'm going to move it to the right one time. And when we go to the right, we're getting 10 times bigger. So in this number sentence, I would say 400, the 4 is 10 times bigger than the 4 in this one. Boom. And then they gave a second example, and we're still going to do the same method where we're going to think about the number and we're going to think, where is my decimal moving? So if it's moving to the right, it's getting bigger, so I'm multiplying by 10. If it's moving to the left, then I'm dividing by 10, or I'm multiplying by 1/10. So I think that's the hardest part to remember, that we're multiplying by 10s if it gets smaller, we're multiplying by 10s if it's getting bigger. Okay, so here was the second example from her homework. She had 1,703,298, and she wanted to know the 2 in this number has blank the value of the 2 in 3,932,574. Okay, so we're comparing 200 has the value of 2,000 times what number? So we're going to do the same thing again. Here's 2,000. Here's my decimal. Where do I want to move it so it gets to 200? And I definitely want it to go this way. I want it to go to the left. So it's getting smaller. So I'm going to multiply by that fraction. So 200 is 1/10 the size. So it's 1/10 of this number. That's it. And she has some other problems in there. I thought this was really interesting. The wording of it makes it a little hard, but I like this analogy of thinking about moving the decimal and figuring out what's happening in terms of tens. I do like the idea of seeing multiplication this way. I can see how division can happen the other way, but the way this child's homework was written, they wanted multiplication in both directions. So for numbers to get smaller, I have to multiply it by a fractional piece. If it's getting bigger, I multiply it the other way. Okay. So let's look at the other homework problem that came up today. And I really wish I can there were some chat rooms this morning. I had about 150 comments and likes and things like that. And I'm trying to find a way to make it public for them so they can actually see it, since these are their problems. And the other problem that came up, I had a mom of a first grader who said she's really having trouble with just with subtraction, and her kid doesn't know how to subtract the traditional method. So I offered her the trade first method, and it looks just like regular subtraction, looks the same. But the idea of it is a little bit different. So let's say I'm doing something like this. What you do in trade first is you're going to start on the left, and all you're going to ask yourself is, do I have enough? That's just my thinking question. Do I have enough? So can I do 5 minus 1? Do I have enough? Yes. I go to the next one. Can I do 0 minus 3? Do I have enough? No. So I have to do some borrowing. So I'm going to regroup, and I'm going to take one of these to make 10 of these. I can get into the actual regrouping a little at a different time. But now I have enough. 10 minus 3 I can do. 0 minus 8, I can't do that. So I'm going to take one of these and move it over here. Now I have enough. And now what I can do is I can subtract, and I can subtract from any side. So 4 minus 4 is 0. 9 minus 3 is 6. 10 minus 8 is 2. There's my subtraction, and I didn't have to do any of the borrowing in the middle. I kind of front loaded and did all the hard stuff first because I traded first. And to check my work, 2 plus 8 is 10. 3 plus 6 is 9. 0 plus 4 is 4. So no different. But think about how different it is when you try the traditional way, and kids have to go, I can't do this, I have to borrow from here. And so I see a lot of kids do this, but there's nothing to borrow, so they kind of have to go from here, and they leave a 10. And they sometimes forget, oh, I did take one from here, and I had to turn that to a 9. So double regrouping, this is where a lot of kids get stuck. I can show you another example again, so you can see what it kind of looks like. So let's say I have 432 and 63 cents, and I want to take let's say this. All right, and I'm going to do it again from the left. We do all our hard work first. Do I have enough? Yes. Do I have enough? No. Okay, now I have enough. Do I have enough? Yes. Do I have enough? Yes. Do I have enough? No. Okay. Now I can, it doesn't matter if you go left to right. I can do it from this side. 13 minus 8 is 5. 5 minus 5 is 0. 2 minus 1 is 1. 13 minus 9 is 4. And 3 minus 2 is 1. And I can check my work by just adding these two digits. 5 and 8 is 13. 0 plus 5 is 5. 1 plus 1 is 2. 4 plus 9 is 13. And 1 plus 2 is 3. And it works out. And if you want to check it the other way just to make sure that this adds up to this number, you absolutely could. And that works too. And my final one from today comes from a really awesome friend of mine, my friend Rashana, who she was also asking a question about her kids' homework. It's a geometry question. I love volume questions. Right now, most kids in New York State I know are doing geometry, especially in grades 6 and 7. 8th grade may be doing something different depending on whether or not they're doing the 8th grade test or the Regents. And so her problem, she had a cube. And each side was 2 feet. So it's 2 by 2 by 2. And then she had a little tiny cube. And this cube was 3 inches by 3 inches by 3 inches. And the question was, how many, a company puts boxes of lotion in that are 3 by 3 inch cubes. The boxes are then packed into this. So this is somehow going to go into this. These little boxes get packed into the big box. How many of these boxes can fit in here to fill it completely? And the first thing I told her was, we have to work on these units. We're talking about feet and inches. Let's make them the same. So we're going to change, it's much easier to change these into inches than this into feet. Because if I only have 3 inches, and I know I need 12, I'm going to be dealing with fractions, 3/12 of a foot. And I don't think we want to see 3 little fractions here. We're going to make the problem harder than it needs to be. But I can turn these into inches. So let's do that. 2 feet. I know that 1 foot has 12 inches, so 2 feet has 24 inches. So 24 by 24 by 24. So we're going to start with that. And I asked her just to think for a little bit. If you had this little box in here, and we know we have 24 inches here, how many of these 3 inches could you fit here? And she told me I could fit 8 of them. And I was like, how do you know? She was like, well, because I know 8 times 3 makes 24. So I hope that part makes sense to you. 1, 2, 3, 4, 5, 6, 7, 8. So think about 3, 6, 9, 12, 15, 18, 21, 24. So I can fit 8 of them this way. So just think this way I can fit 8. Well, how many can I stack on top? And she thought about it. I was like, I can also fit 8. So I can fit 8 this way. And she could also stack 8. So she thought, oh, from here I can just add 8, do the same thing. So I have 1, 2, 3, 4, 5, 6, 7, 8. And how many boxes can fit across this way? And she said, oh, it's just 8. Then it dawned on her, oh, okay, something's going on here. So think about it from the bottom. If you put 8 this way, you have 8 rows of 8, 1 layer of little boxes. 8 by 8, that's 64. And how many of those can you stack on top? So on this layer, there are 64. And she was like, oh, I need 8 layers. So she started thinking like that. And she was like, okay, 1, 2, 3, 4, 5, 6. And we're going to have to make some space. 6, 7, 8. Sorry, it's not pretty anymore. 1, 2, 3, 4, 5, 6, 7, 8. So she started thinking in her head, oh, I have just 8 groups of 64. Like, yeah, that's all you have. And this is a concept that happens actually in 8th grade, where you think of volume in terms of just layers, like layers on a cake. And you can figure out the base first, which we did. We knew it was 8 times 8. I have 64. Now you're just kind of stacking on top. So she's just doing 64 times 8. That's 32, 48, 51. So she has 512 boxes can fit. Then she asked a question, couldn't I have just done 8 times 8 times 8? And this was, if this was 8th grade, I would say yes, you could just figure out what is 8 to the 3rd power, and you would also get 512. But it depends on the age of her student. So there you have it. These were 3 of the questions that came up today as I was just looking through some of the posts. And these are things that just came in, and I am more than happy to do some more work with this. I'll come again, come live again at 3 o'clock. Feel free, please send me more questions. You can either DM them to me, or you can email them to me at, I'll use my math site, sarah@mathminilessons.com. Follow me there. You can just email me there. You can also follow my Facebook group that has the same thing. I just put it back up today, so you can send me more questions, and I am more than happy to help. So these are 4 different types of problems. So I hope this was helpful. I hope you enjoyed it. Please, parents, don't get frustrated. I know this is new. I know this is challenging if I'm speaking fast. If you want more additional help, feel free to just check in with me, and I'm happy to support. Thanks, guys.